So I thought I'd do a demo on the Morlock software, the UI that programs the board. On my machine, it's located on my R drive right here. This is my development for it. If you want the development files, they are available. I have the entire project published. It runs on Visual Studio 2019, and I have to say OK to remote drive. I'm recording this on a monitor slightly smaller than I normally use for video purposes, just so I have a clean desktop, but here it is. You can compile it and run it if you're a developer, and if you're not, then you can say forget this and just run the executable that I sent you. Go on, go away. I know I stopped it. Could have sworn I just, there we go. Alrighty, located here. You may have to install the Visual C redistributable in order to run this if your machine doesn't have it already. It's a standard Microsoft thing. It is included in the download. So I run the program and it may come up immediately with COM error like it just did with me. And what it's telling you is that it couldn't figure out easily where the Morlock was. This is your basic dialog that interfaces with everything. So what we want to do is scan ports, and you'll see all the COM ports that it might choose. And my Morlock is plugged in, and it chose 6 first, and 6 was wrong, so let's try 12. No, 12 works. You see, if this comes up and it populates the dialog, that means that it is communicating with the Morlock just fine. So your options are, I guess I'll start from the top. Single solenoid or dual solenoid tells it what to go into. Single solenoid mode is a very simple fire cycle where it just fires the first one for 12 milliseconds. Up here you have a graphical display of what the fire cycle is. Under dual solenoid, you have the first dwell 1, which say let's set it to 8 milliseconds. This 11 milliseconds is the hold off. So it's going to wait 11 milliseconds before it fires the second solenoid, which is usually connected to the bolt. Important point, this can overlap the sear, the first solenoid if you want or not, doesn't matter. The timing takes that into account. And the dwell 2 is how long it's going to open that bolt for. For an electrococker, this is about right. For your different guns, for say an Excalibur or a Shocker, it may be very different. Next up, trigger active high. This means that the trigger is considered pulled when the voltage on the pin is high, 3.3 volts. That's by default. The trigger header has a sense pin and a plus 3.3 voltage pin. When you short those together, I know short sounds like a bad word, but when you connect them together, it thinks that the trigger has been pulled, and that's the default. If you change this, make sure that you have the header on the board disconnected, because when you change this, it could think the trigger's pulled when it's not. Bad things can happen, so make sure you take the board out of the gun if you change this. Flip screen is whether the OLED screen is upright or high or low. Trigger pull up or pull down. This is kind of an advanced feature. This is whether or not the chip uses pull up and pull down resistors. Normally you want this on. The only time you'd want to turn it off is if you have some kind of externally driven trigger, like the e-cocker that I have has an actual eye that watches the trigger. It's super interesting, and that requires power in order to work. So that's why I had to put this in. Don't mess with this unless you really know what you're doing. And the reason is you will make the board unstable, and in sleep mode you could actually draw quite a bit of power. So make sure that you don't do this. Unless you know what it is, or send a message and I'll be happy to tell you super details. The eye. So when you turn the eye on, by default it's disabled. You'll see that you get a whole bunch of new timing information. The first thing you see at the bottom is a graph telling you how blocked the eye currently is. Now I'm changing the sensor right now. I don't have the camera on me, but I'm pointing the sensor at it. I'm interrupting with my finger, pointing the sensor. You can see what it thinks the sensor is reading. It takes a sample every second. It goes from 0 to 255. Now the red bar in the middle is where you tell it to be active. You say that if it crosses this bar, it is blocked. That's the detection level. Okay. It goes from 0 to 128. I said 256, it goes 0 to 128. Now you see that it's red, that thinks that there's no paintball there. If your eye components think that there is a paintball there, then you need to say sense reverse. Now it thinks that there is a paintball there, and the uh, when the graph is all the way to the right past the detect point, it thinks that there isn't. So this reverses the sense of the kind of as it's described on the tin there. I hold off. This is the amount of time after a ball is detected before it does anything else. So what this blue thing, so the I hold off says that if it wasn't see a ball, let's see that your bolt is open and there is no ball in the chamber, and then one falls in. This is the amount of time before it will start the bolt going forward. You can set this to 0. It's probably pretty harmless, but some guns you might want to give the ball a little bit of time to seat, maybe go against a detent or something. You can set that if you want. If there's already a ball there, then that is ignored. Then you'll see the next thing in the cycle is it fires the bolt forward, and then this is the bolt hold off. This is a kind of a difficult one to explain. This is one of the funny things we discovered when we started putting eyes in guns. When the bolt starts, this is a single solenoid gun. When the bolt starts to retract, if you start looking for a ball right away, what are you going to see? You're going to see the bolt, and because the bolt hasn't retracted yet, it's starting to look before it actually has physically cleared the eye. So this 10 milliseconds bolt hold off says, even after you've told the bolt to close, that's not an instantaneous process. Wait 10 milliseconds for the bolt to actually come back, then start waiting to see if you see another ball. That's what that is for. And that's the same thing in dual solenoid mode. You'll see it's got the same thing where it means something slightly different in this case. What it means is it assumes that there's a ball in the chamber because it's a closed bolt gun. Open the bolt for 50 milliseconds, as much as 200 milliseconds. I'll get to that in a second. And then before you even start looking for a ball, and it's really important in dual solenoid guns, before you even start looking for a ball, wait 10 milliseconds. Then when you do see a ball, wait this amount of time, in this case 2 milliseconds, the hold off, before you close the bolt again. So this is kind of the bolt clearing the sensor time, and this is the ball seating in the chamber time. Like I said, you could set these to 0, that to 0, and this to something small. It would probably be okay, but this lets you really custom tune the gun if there's something that's not working. The 200 milliseconds is the max dwell time. That's the most amount of time it's going to hold the bolt open, 200 milliseconds. So if it doesn't see a ball in 200 milliseconds, it's going to assume one isn't coming and it's going to close the bolt. This is to not drain the battery by holding expensive solenoids open. This 5 up here is the short cycle prevent. So this says that, let's say the 200 milliseconds happens, but you're in a rate of fire of 10, say, really high, 13 balls per second. If that 200 happens, it's going to actually crash into the next cycle. This says no matter how much time you took, no matter how long it took for the bolt to wait for a ball, always tack 5 milliseconds on the end of the fire cycle to keep it from short cycling. Let's put this back to something sane. Not from the good old days of 13.5 and 15 and all those crazy numbers. Next up, battery profile. Set the battery profile to LiPo. This says that it will assume the battery is full if it's at 4.15 volts. It'll assume half at 378 and so on. You can change these to be whatever you want. If I want to say my LiPos are different. They are fully charged. I want to say they're fully charged at 4.1. I want it to notify me that it's at half charge at 3.9. I want to know, right away. You'll note that the number changed. I put in 3.8. I put in 3.90. As soon as I hit enter, it becomes 3.89. The reason for that is what just happened is it actually flashed the board. It actually went and programmed the board, and it can't do exact numbers. It has to approximate a little bit because of the limitations of the circuitry. So it's just telling you that. It's telling you that it can't detect quite 3.9 exactly. The analog to digital converter has some limitations. It shouldn't be a problem in most cases. If you have an external battery hooked up, say a 9 volt is one I kind of looked up. This is what I think the voltages are for full, half, and low. 3 1.5 volt cells, I think it's about this. I don't No, exactly. To tell you the truth, the different batteries, I guessed as best I could, but ultimately you can set your own values, you, whatever you like, whatever matches the batteries that you have, whatever you find works for you. Hopefully you won't have to worry about it. Just use fresh batteries. The rest of this stuff's pretty self-explanatory. This is the default fire mode. This is the fire mode that it's going to be if you turn the power off and on. I think probably want to leave it at semi. Rate of fire, factory reset. This sets all the values to be what it was programmed with, what it was shipped with, in case everything goes south. Um, if you find the need, program lock. If you turn this on, the board will no longer enter programming mode through the trigger. It won't do it. You have to go back through the USB port. Um, the ramp mode. So ramping. If you're in ramp mode, this is how many shots in the string has to be shot close together to be entered. This is what it's going to go into and the timeout. So if you set it to ramp and you fire 3 shots, then it's going to become auto response and it's going to stay auto response until you are leave the trigger alone for 750 milliseconds. Next up, the dimmer is just how dim the LED is on the board. Very exciting. Boost volts. Spent a lot of time on this for one little spinner thing. Um, the board has Morlock board has on board a voltage booster. Of course, the LiPo that it defaults to runs at 3.7 volts, but most solenoids need 6 or 9. It doesn't stay at 9.2 volts all the time. It's kind of inefficient, so it's not hugely inefficient, but uh, it ramps up to 9.2 volts as soon as you pull the trigger. It takes less than a millisecond. It takes about 500 microseconds. You will not notice the delay, I guarantee. And it will then run the voltage for the solenoid up to this volt before firing it. It goes up pretty high. You can go up to 20 volts if you want. I don't know why you'd want to do that. Something about coils and solenoids you should know. The higher voltage you actuate them with, the longer and harder it is for them to. The longer they stay closed, and the harder it is for them to open again. So they'll be snappier, but their reaction time will actually go down. I think I could be wrong about. I know I'm right about the actuation thing, but anyway, just be cautious. Choose a sane value. Get it working. Um, Reset board. This resets the hard reset if you have some kind of problem. It where it's not responding. Hit reset and it actually sends a signal through the USB port. Enter the bootloader. Once you do that, this program doesn't work anymore. So make sure that you mean to do it. There's another video on entering the bootloader. Power cycling it by unplugging the battery, plugging it back in will bring it back. Reset stats, resets the shot stats. Load and save profile. If you want to save this whole setup, you can do so. It saves it into a file, .mbr. You can also load profiles. They're very small, but if you have some profile you like, making your own .3 extension is one of the few pleasures of programming that I really like. One other thing, anti-bolt stick. Now the anti-bolt stick is something that Aerosmith requested years ago. I left it on because it's easy to do. It doesn't take any programming space. There was a gun where if the gun sat idle for more than 10 seconds, 10 minutes, I'm sorry to say 10 minutes, the bolt would actually start to stick to some grommet or something inside the gun, and the first shot would have this terrible drop off. So if you didn't fire for 10 minutes, crawling around in the woods, it would add whatever, in this case 5 milliseconds, to the first dwell only. And it would only do that once just to get the gun back going. And it seemed to solve his problem. So if it solves your problem, great. I would leave it off unless you really, really, really know that you need it and want to play with it. I think that's about it. If there's anything else you want to know, please let me know, either in the comments or post it or send me an email. Thanks for watching.